Okay, so your vocab notebook should be open to the Chapter 7, Lesson 2 notes. Draw a squiggly line underneath the last number. Write today's date, January 11th, 2021. And then we are starting with number 8. Once you have that, go ahead and put your vocab notebook under your science textbook, which should be open to page 328. Thank you to those of you who have done this quickly. Okay, so we're on page 328. Again, if you want to do the mystery science lesson tomorrow, we have to get through this lesson quickly. So you need to be ready to read. You need to be ready to answer questions. You need to be ready to participate in today's lesson and today's discussion. Please sit up straight, feet down, chest pushed in, or chair pushed in so that your chest is just barely touching, so you're in your good listening position. Okay, we are on page 328. Yes.
Will you talk a little bit loud?
I can try to, but you might just need to turn the other ear towards me, because I'm already being like pretty loud. It's right in my throat. Okay, Victoria, please read first. Everybody, finger ready to follow along. I'm not going to have Victoria tell us where we are because we all know where we are. Loud and slow so that everybody, including the camera and the girls at home, can hear, and slow enough that everybody can follow along. Louder.
What are some types of clouds? Clouds form at different heights above Earth's surface. Scientists classify clouds into 3 main types based on how and where they form.
Good. So the reason we have different clouds is because clouds look different and are called different names depending on how high up in the sky they are. Let's see, I'm just going to have everybody read one paragraph today. So thank you, Victoria. Please read next, Mason.
Cumulus.
You got it, that's good.
Cumulus. Clouds are puffy. White clouds that look like cotton balls. They often have a flat bottom.
So we are going to add these types of clouds as vocab words. So what's the first type of cloud, Mason? Cumulus. Make sure you spell it correctly. And what do cumulus clouds look like?
They look like puffy cotton balls.
So look at the definition. The definition is right there. So what does it say about them?
They look like cotton balls.
Read what it says in the book. So cumulus clouds are what?
Or puffy.
Okay, read it. It's just like a regular definition. You're reading it out of the book.
Cumulus clouds are puffy white clouds that look like cotton balls. They often have a flat bottom.
So they are puffy white clouds with a flat bottom. So let's draw a picture. Not a huge picture so that you have space. So they're the ones that look like this. They're the ones that look like this. They're puffy and white, but they have a flat bottom. We can see a picture of them down at the bottom of page 328. If you're drawing the diagram, make sure that you're making the bottom flat. So, and then look at the picture on the bottom of page 328. We see the cumulus clouds all the way to the left. We see that they are white and fluffy, like cotton balls, but they have a flat bottom. Zari, please tell us about please read the next paragraph. Everybody finger following along. Are you?
You've probably seen clouds go dark before a rainstorm. If a cumulus cloud becomes dark and thick, it's called a
Look at the pronunciation key.
cumulonimbus.
Cumulonimbus.
This kind of cloud causes precipitation.
So, let's add our next type of cloud. Zari, what's our next type of cloud?
Cumulonimbus.
Cumulonimbus. Cumulonimbus. Cumulonimbus. And Zari, what is a cumulonimbus cloud? What does it start as? What kind of cloud does a cumulonimbus cloud start as?
As a cumulus cloud.
So a cumulonimbus cloud is a cumulus cloud that has done what?
Become darker.
That has become dark. What else?
Before a rainstorm.
Well, it's a cumulus cloud that has become dark and what? What else does the book say? Come on, guys. We're just doing the same thing we do with the yellow words. We're looking at the words that come around it and putting them as our definition. A cumulus cloud that has become dark
And thick.
and thick.
Before a rainstorm.
So what is inside that cumulonimbus cloud that has caused it to become dark and thick? Zari?
Water.
What specifically? What is it about? Okay, what is it about to become?
Rain.
Which is a form of, because it's not always rain. Aaron? Good. So a cumulonimbus cloud is a cumulus cloud that has become dark and thick with precipitation. So, the difference between a cumulus and a cumulonimbus is that a cumulus cloud, bless you, is even bigger and fluffier. It still has the flat bottom though, but what does it look like? What happened to it? It got thicker and it's going to get, Zadie? Darker. Because what is it filled with? Zadie?
Water.
Water. That is about to become what?
Rain.
Precipitation. Because rain is a type. It might not just be rain. It could have some other type of precipitation. Okay, so there's the difference between cumulonimbus and cumulus. Cumulus is smaller, it's white, it's fluffy. It's not about to cause precipitation. Cumulonimbus, remember, as that water condenses into clouds, it eventually gets thicker and thicker and heavier until what happens? Michaela?
Until they get so big that it starts.
Then precipitation. It gets so big and heavy that then precipitation starts. We're not going to say rain because it could be rain, but there's some other forms of precipitation that we'll talk about later. Okay. Read next, Michaela. Make sure that you guys use the pronunciation keys. Go ahead. Everybody finger following along.
Stratus. Stratus clouds from and layers.
Not from.
Form in layers. The layers look like sheets or blankets. Stratus clouds are often the lowest cloud in the sky.
Okay, pause. What's our next vocab word?
Stratus.
Stratus. And what are stratus clouds?
Stratus clouds form in layers.
So they are clouds that form in layers. What else? is important about them?
The layers look like sheets or blankets.
So they are clouds that form in layers that look like sheets. We'll just say sheets because we know blankets are sheets are a type of blanket, a thin blanket. What else is important to know about them?
Stratus clouds are often the lowest clouds in the sky.
So stratus are clouds that form in layers that look like sheets. And are often the lowest in the sky. So stratus clouds are those ones that kind of look like this. They're long and flat. Kind of like that. They're usually the lowest in the sky. You can see a better picture on the bottom of page 328 in the middle. So those times when you look out and you just see little bits of blue sky peeking through, what kind of clouds are those? When you look outside and you just see little bits of blue peeking through and everything else is just a cloud, what kind is that? Mason? Stratus, probably stratus. They are kind of flat, they are low to the ground, and there's something else important about them, but we're not going to add them. But it's an important fact. It's something that you can tell your parents when you get home. It's an interesting fact. So Michaela, when you're ready, count to 10 slowly, but not ridiculously slowly. And then you may begin. Everybody, finger ready to follow along when you're done.
What we call fog is really a stratus cloud near Earth's surface.
So, is fog? What is fog? Ethan?
Stratus cloud.
A cloud. Fog is a cloud. Specifically, what type?
A stratus.
A stratus cloud. So when we're driving through fog, what are you actually driving through? Class. The clouds. So if you think the only way you will ever get to be in a cloud is by being on an airplane, is that true? Nope. Sometimes here in Memphis, Tennessee, which is extremely flat, we're driving in the clouds. If it's foggy outside, you're driving right through a cloud. What type of cloud? Zari?
Stratus.
A stratus cloud. Okay, Michaela, read that last sentence.
Like cumulose.
Not cumulose. Cumulo. Cum. You. Low. Nim. Bus. So put it all together. Cumulonimbus. Cumulonimbus. Separate the syllables. Cumulonimbus. Cumulonimbus.
Like cumulonimbus clouds, stratus clouds can form precipitation.
Think about when you've driven through fog, or when you stood outside in the fog. What does the air kind of feel like? What do you feel in the air? Or what do you see on your car, bless you, when you drive through fog? Smith?
Like a little bit of water.
A little bit of water. That's because stratus clouds can also form precipitation. So if you're driving right through it, what's inside that cloud that's getting ready to fall? Smith? Can somebody help her out? Mason?
Water.
Water, specifically what? That's about to be what?
Precipitation.
Precipitation. So stratus and cumulonimbus clouds can form precipitation. They're the ones that have gotten really heavy and they're ready to fall as precipitation. Okay, I'm going to have to erase because I can't fit the next one. Thank you, Michaela. I'll leave number 9 up. You can see a better picture of what stratus clouds look like over on the bottom of page 328. Please read next. Zadie, loud and slow. Cirrus or cirrus? I say cirrus, but this does make it look like it's supposed to be cirrus, so let's call them cirrus.
Cirrus clouds look thin, wispy, or feathery. They are made of tiny bits of ice. Cirrus clouds are usually found very high in the sky.
So, what's our next word, Zadie?
Cirrus.
Cirrus. Cirrus clouds are clouds that are what? What is their appearance?
They look thin, wispy, or feathery.
Let's take out R and put look instead. Clouds that look thin, wispy, or feathery. What else is important to know about them, Zadie?
They are made of tiny bits of ice.
So they're clouds that look thin, wispy, or feathery. All of these words, if you can't read them up here, they're all in your book. And are made of tiny bits of ice. What else is important to know about them?
They are usually found very high in the sky.
So they are clouds that look thin, wispy, or feathery and are made of tiny bits of ice that are usually very high in the sky. We can see the cirrus clouds by looking at the picture on the right on page 328. So there are those like, bless you, there are those very like wispy, feathery ones that sometimes you see when it's not a super cloudy day. And it looks like somebody has just like painted them in the sky. They don't look fluffy. They don't look thick. You can see them on the right, on the bottom on page 328. They're made of tiny bits of ice. Well, we know as we go further up in the troposphere, what happens to the temperature? As we go up into the troposphere, what happens to the temperature? Smith.
It gets colder.
It gets colder. And we know clouds are made of tiny droplets of what? Clouds, all clouds are made of tiny droplets of what? Aaron? Water. What happens to water as it gets colder? Aaron? Or actually, no, What happens to water as it gets colder? Michaela? It turns into ice. So that tells you, okay, I know clouds are made of tiny droplets of water. The higher you go in the troposphere, the colder it is. So if cirrus clouds are made out of tiny bits of ice, that means they must be really high up because those tiny bits of water that make the cirrus clouds have frozen into tiny bits of ice. Does that mean if there are cirrus clouds in the sky that it's going to snow? Can we have cirrus clouds in the summer? Have you seen clouds like this in the middle of summer when it's really hot? Yeah. So just because they're made of ice, does that mean that that ice is going to make it all the way to the ground? No. If they did form precipitation, which I don't think that they can, it would definitely melt if it was hot by the time it got to the ground. Okay. Erase cumulonimbus, even though I don't actually think I need to do that yet. But I will on the next page. So, read that last little paragraph on page 329. Then we're going to look at the diagram. Why should you be sure to pay close attention when I talk about this diagram? What might happen? Michaela? It might not our outline. When I say pay attention to this diagram, where do you usually see it again? Cullen?
You might see it.
Mason?
You might see it on the test.
Not on your test. Aaron? On our independent practice or morning work if we run out of time. Okay. Read that last, Ethan, read that last paragraph. You're the one I called.
Okay.
Loud and slow.
Cirrus clouds.
We already read about that. Okay. Well, you're not ready, so I have to call on somebody else. Remember, being ready for science or reading or anywhere where we have a textbook means your face shield's on. Aaron, loud and slow.
Observing clouds. In the diagram I read, you can see other cloud types. Often, you can find more than one cloud type in the sky at one time.
We know that. Sometimes we see those fluffy clouds, those white fluffy clouds, the cumulus clouds, but then we also see some stratus clouds, or maybe we also see like a fluffy cumulus cloud here and there, and then the cirrus clouds way high up in the sky. You've probably noticed that, or maybe you haven't, but now I bet you will. Well, if we look at this diagram on the right, on page 329, we can see several different clouds. Now, these are usually about the levels that they form. So, of these clouds, which one forms the closest to the ground? Which one forms the closest to Earth's surface? Victoria.
The one that is closest to the ground is stratus.
Are you looking at the diagram on page 329? I don't see any stratus clouds on there. Who can help her out? Mason. Cumulonimbus. We know that usually stratus clouds are the closest to the ground, but do we always see stratus clouds? No. So in this diagram, do we see any stratus clouds, Victoria? No. So are we worried about stratus clouds right now? No. So which clouds are usually the second closest to the ground? Now that we know this. Kingston? Think about what we know. We know stratus are usually the closest to the ground. So which other ones are usually the second closest to the ground, do you think? Cumulonimbus. Okay? What are the clouds in this diagram that are the highest? Smith.
Cirrus.
Cirrus or cirrus clouds, which we could have already guessed because we know what about cirrus clouds? Smith?
They're really high in the air.
They're usually very high in the sky. They're usually the highest. Well, we see on this diagram, they're the highest here too. Then we see some in between. We see alto cumulus, find alto cumulus. And then we go a little higher and we see cirrocumulus. Ooh, look at the cirrocumulus clouds. They kind of look like a mixture of the thin, wispy, feathery cirrus clouds and the fluffy cumulus or cumulonimbus clouds. They kind of look like a mixture. So if you see those ones that look like a mixture, like little pieces, well, now you know they're cirrocumulus. Okay. What type of clouds do you think are in the sky today? Let's see, I haven't called on somebody at home in a while. Zari.
Cumulus.
Well, cumulus clouds do not form precipitation. And it's snowing right now, which is a form of precipitation. So there's one of two clouds that it could be. Zadie?
Sir.
Do cirrus clouds form precipitation? Michaela?
Stratus.
Could be stratus. What other one could it be? Kingston? Cumulonimbus. Remember, cirrus are way high up in the sky. They're thin and wispy. So if the whole sky is covered in clouds, would they be cirrus clouds? Would they? Why would they not be cirrus clouds? If the whole sky is covered in clouds, you can't see blue sky at all. Why would they not be cirrus? Mason?
Because they're really high in the sky.
Well, they're really high in the sky, but why else? How do we know that if the whole sky is covered in clouds, they're not cirrus clouds? Michaela?
Because they're dense.
Cirrus clouds are what? Thin and wispy. So we can see, if we look at this picture, we can see the blue sky through most of them. So if the sky is completely covered, it is either stratus clouds because they can cover the whole, they're like a blanket, or it could be a bunch of cumulonimbus clouds all pushed together into where it looks like almost one big cloud. Okay, let's turn the page and let's talk about other forms of precipitation, because when we're talking about precipitation, we don't just mean rain. Rain is just one form of precipitation. Now this is where some of you got real confused on your vocab. You got to pay close attention to what these are. Okay, please go ahead and read next, me. Everybody ready to follow along? Finger ready? On page 330. Follow along as I read. What are other forms of precipitation? Rain is just one form of precipitation. Water can change state as it moves through the air. When this happens, other kinds of precipitation may fall. So sometimes as water is falling through the air, it may change from a liquid to a solid, or it could change from a solid to a liquid. Sometimes it starts as a liquid, ends as a liquid. So let's figure out, what are those states? What does that mean? Go ahead and read the next paragraph. Carla, loud and slow. Everybody pay close attention. So Carla, go slow. Make sure you're not leaving any words out. Make sure you're reading the words correctly. Go slow. Point to each word as you read it.
No. When water reaches a temperature below 0 centimeters,
0 degrees Celsius,
0 degrees Celsius,
or
32 Fahrenheit,
degrees Fahrenheit,
Fahrenheit, it freezes to ice. Remember, to freeze, it changes from a liquid to a solid. Bits of ice can collect in a cloud. If they get too heavy, they fall as snow.
So, we're going to draw a picture. Carla, don't forget to mute yourself. We're going to draw a picture. Here is a cumulonimbus cloud. So it's dark on the bottom. And it's way high up in the air, and it's real cold. It's cold high up in the air. It's cold on the surface of the earth. So what's happening is those tiny droplets of water are freezing inside the cloud as ice. Probably should be standing on the ground. Now, it is cold up here. We'll say 0 degrees Celsius up here. It is also cold on Earth, 0 degrees Celsius. That means these little bits of ice start to fall and they stay frozen. This is snow. The water freezes in the cloud. It stays frozen as it falls. It does not melt. So the bits of ice collect in the cloud and then they fall to the ground as snow. Bless you. That's how we get snow. So today, where is this water freezing? Smith?
Inside of the cloud.
Inside of the cloud. It's really, really cold here on Earth. So is it melting as it falls to the ground? No, it's not. It's still snow. Well, read the next paragraph. Kingston, loud and slow.
When water reaches a temperature below 0 degrees Celsius,
Oh, we already read that. Okay. Smith, please read.
Snow may melt as it falls to the ground. To melt, it is to change from a solid to a liquid.
Okay, we're going to put
Melting?
this definition in later. Let's finish our diagrams, then we'll put that definition in, okay? Okay, Smith, keep going.
Melting happens when sunshine or warm air heats the icy snowflakes. The heat makes the snow change to rain.
Okay, so now let's draw our different diagram. There's snow. Our first diagram is snow. Now, we have a cumulonimbus cloud. And inside of it, it is 0 degrees Celsius. And we've got some snow. Make sure that you're showing snow is different from drops because otherwise you'll get confused. And here's the ground where it is .10 Celsius. So that's cold, but not freezing cold. It's cold, but it's not super, super, super cold. It's like 40 or 50 degrees. So it's like what we think of as 40 or 50 degrees Fahrenheit. That's where .10 is. So we need a jacket, but it's not super cold. Well, it starts to fall as snow, but then it gets warmer. What happens to that snow? What process does it go through? Zadie.
It melts.
It melts and turns into what? It started as snow in that cold cloud, but then what happened to it?
It melts and turns into rain.
It melted and turned into rain. So we have rain. Okay. Please read next. Cullen. Please make sure that as you're drawing, you are showing a difference between snow and rain. Okay? That's why I made snow like little stars, like snowflake shaped things, and rain as drops. Okay, Cullen, read next.
Can I go?
Yes.
Sleet and hail. Sometimes rain falls from clouds as a liquid, but freezes along the way. Rain turns into small chunks of ice. The ice that falls to the ground is called sleet.
So, let's draw a third diagram. We have our cloud, our cumulonimbus cloud. Real dark and heavy at the bottom. And inside the cloud, it's about .10 Cool, but not freezing. We have our tiny droplets of water. They start, then we have our ground and our person. But on the ground, it's 0 degrees Celsius. It's like 32 degrees outside. It's pretty cold. Well, it starts to fall as rain, but then what happens, what process do those tiny droplets of water go through as they get down to where it's cooler? What process do they go through? They do what? Cullen? What's that process called?
They
started as a liquid, but it got colder, so they
turned into.
what is that process called? Zadie?
It froze.
They froze and turned into little pieces of ice. We're not going to going to draw snowflakes because it's a little different. Snowflakes start in the cloud as ice and they leave as ice. Sleet starts in the cloud as ice and ends as melted water droplets. Sleet starts as water droplets and becomes ice. So I'm going to make them like these little things. Do you see the difference? It's not quite a snowflake, but it's not water droplets either. It's these solid little pieces of ice. So there's sleet. For snow, it starts as a solid, ends as a solid. For rain, when it's cool out, it starts as a solid, melts into a liquid. For sleet, it starts as a liquid because up in the clouds is actually a little bit warmer, which happens sometimes, and then freezes as it comes down to earth. So does everybody see the difference? We have one more type of precipitation. Zadie, when you're ready, read the last paragraph, loud and slow.
Hail is made of ice too. The ice chunks are much larger than sleet. Hail forms inside of the tall clouds of a thunderstorm. Most hailstones are the size of peas. However, some are bigger than baseballs.
Okay, so we have our last diagram. Also, make sure you're labeling the temperature and the what precipitation it is. So again, we have our cumulonimbus cloud. It's real dark at the bottom. And this time, it really doesn't matter. We'll say that the cloud is at like 0 degrees Celsius, but the temperature on Earth does not matter. For hail, it could be 40 degrees Celsius, which is like 80 or 90 degrees Fahrenheit. So it could be hot on the ground. Hail can happen whenever. Because what happens is these really big chunks of ice form inside the cloud. These really big, solid chunks of ice form in the cloud. Do you see those big chunks of ice? Do you see how they're different from the small chunks of ice that sleet and the snowflakes? Then what happens is they fall as, oops, here's our man on the ground. They fall as larger, they're larger than sleet. So you know what, I'm afraid to, I wish I'd done sleet as like this. Would it be too hard for you guys to go back and erase the sleet and make little dots? Okay, so let's erase because these are a little too big. They look more like hailstones. So go back to sleet and change it from the big dots to like tiny little dots. Do you see how they're not raindrops, they're not snowflakes, they're just small, teeny, tiny pieces of ice?
Yes.
The water that fell from the cloud, the warmer cloud, the slightly warmer cloud, has melted into these tiny droplets of ice. That's sleet. Well, hail, they're not as big, usually, as the ones in the cloud, but they do fall as bigger pieces of ice. And there is hail. Why do you think that hail can fall even when it's warm out? Why do you think hail can fall even when it's warm out? Michaela?
Because of big pieces of ice.
Very good. Because in the cloud, it's really big pieces of ice. And think about it, even on a really hot day, it takes imagine you had a big block of ice. It would take a lot longer for that big block of ice to melt, even if it's sitting out in the sun, than a little ice cube, right? A little ice cube would probably melt in like 30 seconds if it's really hot outside and you put it on the ground. But a big giant ice block like this, think of like what's his name? Oh my gosh, why can't I remember his name? Is it Kristoff in Frozen? You know how he
Yeah.
that's his name. I don't know, I'm having a brain fart. He has those big blocks of ice. So imagine one of those big blocks of ice on the driveway. Imagine one of those big blocks of ice on the driveway in the summer. It would melt eventually, but it would take a while. But a little ice cube, if you put it on the driveway in the summer, it'd be gone pretty quickly. So that's why the pieces of ice are so large up in the clouds that they melt some as they fall. So they do start out bigger. They melt some as they fall. But they don't melt all the way. They're too big. They start out too big to melt completely by the time they hit the earth. And that's why we get hail. That's why it can happen even when it's warm out or even hot out. Because they start as such big pieces that they don't have a chance to completely melt as they hit the ground. So does everybody understand the difference between snow, rain, sleet, and hail? Which forms of precipitation start in the clouds as ice? Which forms of precipitation start in the clouds as ice? Zadie.
Sleet.
Sleet. Does sleet start as ice? Look at the definition. It says the ice, let's see, it says sometimes rain falls from clouds as a liquid but freezes along the way. The rain turns into small chunks of ice. The ice that falls to the ground is called sleet. So sleet starts in the clouds as what, Zadie? A solid or a liquid? A liquid. And then as it falls, it becomes a solid. So does sleet start in the clouds as ice? No. Who can help her out? Victoria. Snow. Snow starts as ice or a solid. What does snow end as? What state of matter? Liquid, gas, solid. It starts in the clouds as a solid. It ends as a... Who can help her out? I think that some of you are just going to say solid because it's the only other option. Snow freezes in the clouds. If it's frozen, what state is it in? Kingston. Solid. It stays frozen as it falls to the ground. So it stays in what state, Kingston? Solid. Also, look, the liquid are little drops. The solids are either snowflakes or chunks of ice. Okay, so we know snow starts in the clouds as frozen. We know it ends frozen as it falls. What other form of precipitation starts in the clouds as frozen, as a solid? Michaela? Hail. Hail starts as a solid. What does it end as? A solid or a liquid? A solid. It stays a solid because it's too big to completely melt. What else starts as a solid in the clouds? What else starts as a solid in the clouds? We know snow starts and ends as a solid. We know hail starts and ends as a solid. What else starts as a solid in the clouds? Zari.
Sleet.
We already answered this. Does sleet start in the clouds as ice or as a solid? Look at that paragraph, Zari. What does it say that sleet starts as?
A liquid.
A liquid. So does sleet answer the question, what other form of precipitation starts as a solid in the clouds? No. Smith, what other form of precipitation starts in the clouds as ice or as a solid?
Rain.
Rain. Now this is not always the case, but it is when it's cool outside. Yes, but then what happens as that ice falls to the ground if it's not cold enough? Smith?
It melts.
It melts and it becomes a
Liquid.
liquid. It falls as rain. Okay, and sleet. Sleet starts in the clouds as what? Sleet starts in the clouds as what? Cullen.
Rain.
A what? Liquid, gas, solid.
Oh, liquid.
Liquid. And then as it falls to the ground, what happens to it? Aaron? It turns into a solid. What is that process called when something changes from a liquid to a solid? It freezes. Very good. Now let's add that vocab word underneath our diagrams. So number 12. Who was it? Smith, was it you that read that paragraph? Okay, Smith, what is our last vocab word?
Melt.
Melt. And what does the word melt mean? We're going to say it's the process of a what changing into a what, Smith?
Of a solid changing into a liquid.
Good. So melt means the process of a solid changing to a liquid. So that means if I take an ice cube is what? Solid, liquid, or gas? Zadie?
Solid.
Solid. And I put it in a pot and I heat the pot up. What happens to that ice cube, Zadie?
It melts.
It melts, which means it's changing from that solid ice cube into what?
A liquid.
A liquid, that liquid water. Okay, any questions about this type of precipitation? We have about 5 minutes before we pack up, so I want you to make sure that your diagrams are labeled correctly. Otherwise, they won't mean anything. If you don't say what type of precipitation it shows, it's not going to mean much. If you don't have the temperatures written, that means you're not going to be able to tell what's happening to that precipitation as it falls. Is it starting out really cold and ending cold, so it's staying a solid? Is it starting out cold but then warming up, so starting as a solid, ending as a liquid? Is it starting out warmer and then ending colder, starting as a liquid, ending as a solid? Or is it just such a large, cold solid that even no matter what the temperature is as it falls, it stays a solid? Make sure you have that written correctly.